Welcome to another problem session. So we are doing the paper from paper 2 this year JEE, and so this is question number 13. Question 13 is really interesting one. So you have there are two compartments, and so this is a piston that can freely move. At equilibrium, it comes halfway, and that's equilibrium condition. Okay, meaning if I look at this, let's look at this piston. If you look at the force on the piston, then it's all balanced. That's what it means here. So over there is N is 3/2, and in this part of chamber is one of an ideal gas. It doesn't say monatomic, diatomic, and it could be anything. Could be, doesn't say same gas, different gas. Could be nitrogen, oxygen. You just say ideal gas. That's it. The natural length of the spring is about 4/5. This much is the natural length. 2/5L is the natural length, and this is delta X of the spring. Okay, so spring is extended. That would mean the force is that side. K delta X is that side. And that's actually very critical, because if pressure on the left side is P1, pressure is P1 on this side, and pressure is P2 this side, P2 is said to be P in here, right chamber is P, and that's what we're supposed to find. Then okay, so need to find this P and show that P can be written as like this kind of expression, and then this alpha is its value we have to find out. Okay, so equilibrium condition. That's the one you have to set it up. So and let the area of this thing be A, area of this piston be A, the area of this thing is A. Then so this is the x-axis, K L/2 minus 2/5L, that's the extension. Pointing that way, this is positive. P1 is that way. P2 equals to P is that way. But this is not force. You have to multiply by area. So E times, so this force is pressure times area. The pressure is how much force these molecules on this side is applying on this piston from the right side per unit area, right? So these are the forces on piston. Okay, so this must equal to this plus this. So P1A must equal to PA plus K. So this half minus 2/5 will just be 10 here. 5 minus 4 is 1/10. K over 10 L. Okay. So this would be one equation. Second equation will come from equilibrium of temperature. Temperature this side is must be the same as this side. Another thing we find is the volume here is same as volume here. So temperature same. Will mean P1 V1 over N1 R equals to temperature equals to P2 V2 over N2 R. Okay, and of course this is the P for us. So this equal to that. Let's write that down one more time. So forget about this. R cancels out, and here it just happens the volume in one chamber is equal to volume in the second chamber. That also cancels out. Then P1 equals N1 over N2 P. N1 is 3/2 and N2 is 1. So this becomes 3/2 over 1. P is 3/2 capital P. So this is my second equation. So I put this over here. So 2 in 1 gives you 3/2 P, and of A equals to PA plus KL over 10. Simplifying half PA because KL over 10, that means P equals to KL over A 2 by 10. So that's what the alpha should be. So alpha is 2 by 10 0.2. Okay, let's recap. So a couple of concepts here. So if I have a gas, if it's applying a pressure P and area is A, so that's equal to force is applying P times A. So that's one concept that you had to know. Second is identifying the forces and their directions. Forces and their directions, very important. Third was balancing the forces. And the fourth concept was the temperature has to be same. So T on both sides. So this is one equation on the left side, and the other side of the chambers, same equation, the same T. So equating the T equal gave us P1 over N1 equals P2 over N2, and then just getting that out. So these were the basic concepts they were testing. I would rate it a pretty simple problem, and actually getting this kind of problem right in a test like this is very important. Sometimes there are problems which have some giveaway. So this is kind of like a giveaway problem. All right. I think that's it. And in the next problem, I'll see you. Bye.